Welcome to the ATC Knowledge Channel presentation of troubleshooting for the K101 and M panel tank monitoring systems. The system design has been utilized by the RV industry for more than 30 years. In this video, we will demonstrate the proper process for determining the point of failure for your tank level monitoring system. We will begin with a discussion of the components that make up the system.
The following is a general disclaimer. This video is intended for use by qualified and certified technicians only. It demonstrates procedures and techniques that require specialized knowledge, training, tools, and equipment. The instructions are not a substitute for professional training or certification. Concerning the assumption of risk, American Technology Components, ATC, assumes no liability for injury, property damage, or equipment failure resulting from the improper use of the information contained in this video. By following these instructions, you acknowledge and accept all risks associated with performing these procedures. If you are not a trained professional, please do not attempt to replicate the actions shown. Always consult a qualified expert for technical assistance. Important safety information to take into consideration when reviewing the information presented in this video is as follows. Always follow all local, state, and federal safety regulations. Wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. Ensure that all power is disconnected before beginning any work. Working with high voltage or complex machinery can be dangerous and should only be performed by a professional. You will see a number of these monitor panels and convenience centers with the KIB electronics logo on them. On April 15th, 2019, ATC acquired KIB Electronics. There are slight differences in the products they produced, but the overall troubleshooting and operation are the same. The information contained in this video is applicable to both ATC and KIB products. For more detailed information, please review our channel contents for additional videos. If you cannot find the product you are looking for, feel free to email us at service@atcomp.com. The typical tank-level monitoring system is made up of 4 components: the MP5 tank probes, the K101 resistor bridge, the circuit board, and the vehicle wiring. In this video, we will discuss the diagnostic procedure for each of the ATC components that make up the system. We will not discuss the vehicle wiring. The vehicle wiring is the responsibility of the vehicle manufacturer. We will begin with the K101. This is the most commonly misdiagnosed component in the system.
Attached to every tank to be measured is the K101 resistor bridge. Many people will refer to this as a sensor or diode pack. Neither of these descriptions are accurate. The construction of the K101 is simply 2 resistors with 4 wires connected at strategic points to provide a pathway for voltage to produce a specific result from a reference voltage from the associated monitor panel. The resistors and connections are encased in plastic for the protection of the components from corrosion. There are no serviceable components with this K101. Testing of the K101 is simple and quick. You will need a multimeter, preferably digital, set to measure resistance. Most meters will show that as the omega symbol or the horseshoe. When testing the K101, it is important to disconnect all the wires from the tank. It is possible for a buildup inside of the tank to act as an additional conductor and provide inaccurate readings, resulting in a failed operation of the tank level monitor. It is important to note that your body is a conductor of electricity. When measuring resistance, it is preferred to use alligator clamps so that your body resistance doesn't influence the reading of the K101. In the event that you don't have them, be sure to hold the insulated portions of the lead as to not interfere with the readings. Meta. To test the functionality of the K101, start by connecting your red meter lead to the red wire of the K101. Then connect your black meter lead to the orange wire of the K101. Your meter should read between 0 and 1 ohm. If it does not, the K101 has internally failed. If it does measure between 0 and 1 ohm, then place your black meter lead on the green wire of the K101. Your meter should read between 64.6 kiloohms and 71.4 kiloohms. If it does not, the K101 has internally failed. If it does measure between 64.6 kiloohms and 71.4 kiloohms, then place your black meter lead on the yellow wire of the K101. Your meter should read 178.6 kiloohms to 197.4 kiloohms. To recap, if you measure 0 to 1 ohms between the red and orange wire, and you measure 64.6 to 71.4 kiloohms between the red and green wire, and you measure 178.6 and 197.4 kiloohms between the red and yellow wire, your component is operating as designed, and your issue is with another part of the system. The K101 orange, green, and yellow wires are connected to the MP5 tank probe. This is simply an M4 bolt with a rubber grommet, washer, and 2 M4 nuts. The only warrantable failure of the MP5 tank probe is a failure of the rubber grommet. Other possible issues with the MP5 tank probe would include excessive corrosion on the head of the probe, resulting in an inability to conduct electricity, a buildup of materials within the tank resulting in a path for current to go from probe to probe regardless of tank level, an improper installation of the probe, such as not installing the probes at least 10 inches away from the ground probe, are all reason for failure associated with the MP5 tank probe. This component is not a sensor and has no intelligence installed that can be compromised. It is a bolt made of metal that is used to conduct electrical current. Upon removing the K101 from testing, you can perform the same continuity testing between the probes of the tank. With the tank empty, you should read OL on your meter between each and every probe. If not, the inside of the tank is coated and requires thorough cleaning or replacement. The final part of the tank level monitoring system is the control board. It can be found in a micro monitor panel such as this, or in a convenience center such as this. The testing for the operation of the panel is also quick and simple, as in the diagnostics for the K101. We will use an M28 micro monitor as an example to demonstrate the testing of the panel circuit board. You will find a plastic red block connector on each one of our circuit boards. The number of wires will vary between 6 and 10. Pin 1 will be red and represent incoming 12-volt DC power. Pin 2 will be white and represent chassis ground. In most cases, the color code for the remaining wires will be as follows. In the event that a board is built different, there will be a white sticker on the board explaining the color code of the connector. In this case, after the white will be a gray wire that will attach to the K101 for the gray tank. Next, you will find a brown wire that will attach to the K101 for the black tank. Then you will see a black wire for the gray 2 tank, sometimes referred to as the galley tank. Finally, you see the blue wire that will be attached to the K101 of the freshwater tank. To begin testing, you will press and hold the battery button. All the LEDs should light up. If one of the LEDs fail to illuminate, verify adequate battery power. You will need a fully charged battery with more than 12.7 volts. If you do not have adequate voltage, charge the battery and try again. If you have proper voltage and one or more of the LEDs fail to illuminate, then the board has failed and requires replacement. But if all the LEDs illuminate, then you can proceed to test the individual level indications. You may experience the following failures. The tank is always reading empty. The tank is always reading full. In these situations, you can select the appropriate wire from the red block connector and follow it to the coach harness. Gray wire for the gray tank, brown wire for the black tank, blue wire for the freshwater tank.
Once you have selected the appropriate wire, follow the wire from the red block connector on the circuit board to the vehicle harness connection. This connection is typically 6 inches away from the red block connector and can be Wagos, bell caps, QD connectors, or mate and lock connectors depending on the OEM connection requests. We will demonstrate with the freshwater tank. The testing for all other tanks will remain the same. When testing the freshwater tank, find the blue wire in the red block connector and follow it to the vehicle harness connection. Disconnect the blue wire from the vehicle harness and then press fresh. The monitor should read empty. Then connect the blue wire from the red block connector to a ground wire. Ground wire in the RV industry are usually white. Then press the fresh button again and the monitor should read full. If these two actions produce the response as indicated in this section, your circuit board is operating as designed and your issue is within your vehicle harness. If you do not get the response as described, the board has failed and should be replaced. You can contact your vehicle manufacturer or dealer for replacement parts. We appreciate you taking the time to watch our presentation of troubleshooting for the tank level monitoring system. We hope this information has been of use to you. If you have further questions, please reach out to us at 574-218-7388. Have an amazing day.